Welcome to Module 6. Module 6 is about calculating statistical numbers, and there are two categories. One is the essential tendency, and as you learn to do these calculations, you see that some of them are cumbersome to do by hand. So my recommendation is that unless your teacher tells you otherwise, I'll do everything in Excel. So I'll show you how to do those calculations in Excel in this tutorial. First, I'll describe the definitions and I'll show you how to calculate them in Excel. So the first category is central tendency. And this is a measure of central tendency that describes the centeredness of the data. And there are a few numbers. First one is the mean. Mean is just another name for average. And if I ask you to calculate the average, what you would do is add everything up and divide it by how many the numbers there are. So in this case, there are 10 numbers. So if I were to ask you to do by hand, you add them up and divide it by 10. In Excel, we use the average function. The second number you will need to know how to calculate is the median. It's just the middle number of all the numbers sorted from large to small or small to large. And if the number of values is odd, it's the middle number. If the number of values is even, it's the average of the middle two numbers. So in this case, there are 10 numbers. So the 39 and 40, you take the average of 39 and 40 if you were to do by hand. In Excel, use the median function. The next one is a mode. It's the number that has the most with the most frequency. So in this case, you see there are two 39s and two 44s. So for this particular example, this is called a bimodal because there are two modes. So in Excel, you use the mode multi function if you know there are going to be multiple modes, or just simply just a mode. Right, so that's the first category. The second category is a variation. Variation, you want to know how widespread the data set is. So there are a couple numbers you're going to calculate. Graphically speaking, if it's low variation, it's pretty skinny. Moderate variation, it's just moderate, and if it's high variation, it's pretty widespread out. So the range is the first number. The range is just basically the difference of a maximum number minus the minimum number. And unfortunately, there's no range function in Excel. So what we'll do is use the maximum function and min function in Excel and calculate the difference between the two. Mid-range is just the average of the highest and the lowest numbers. So again, there's no mid-range function in Excel. So what we'll do is manually calculate the maximum value and minimum value, add the two together, and divide it by 2. So we'll use max and min. Another thing you need to calculate is a standard deviation. It is the most commonly used number to describe variation. So if you were to do this by hand, here's a formula. You need to know the sample size. This x bar describes the average, so you will calculate each deviation from the mean, so x minus x bar, and there's your formula. If you were to do this by hand, here's how you do it. List all the data values, calculate the mean, which is 10. Take the difference between the two, so 2 minus 10 is negative 8 all the way down, and then for each one of them, square them. And then you add them up. That's what the sum part is. And divide it by how many they are. So there are 5 of them. So 5 minus 1, that's 4. You do this calculation. This is fairly easy because there are only 5 numbers. But let's say there are 10 numbers. Then the calculation gets a little cumbersome. So you should use Excel to do standard deviation calculation. And for that, you use stdev.s function to calculate the standard deviations. As you can see, the numbers match. So let's go to Excel to show you, and then I'll show you how to do all these calculations in Excel. So here are the 10 numbers, and I need to calculate the mean, median, mode, the range, and then the mid-range. So for the mean, you use the average function. So the equal sign, average, and select all these numbers. Same thing for the median. You type in equal sign median, open parentheses, and then select all these numbers and press enter, or close parentheses and then press enter. Boom, that's your median. Same thing with the mode. For the range, since we don't have a range function, what we'll do is take the difference of the max numbers minus the minimum numbers. So type in equal sign max, select the numbers, close parentheses, minus min, open parentheses, select all these numbers, close parentheses, press enter. You get the range of 23. For the mid-range, it's the average of the difference of maximum number and the minimum number. So you have to be careful here. Equal sign parentheses, because we want to first calculate the difference of the max and min. So you need to put the parentheses here and then parentheses at the end. And then divided by 2 because you want to take the average. Once you do that, you should get 11.5. So now let's go to the variation. So to calculate the standard deviation and variance in Excel, list all the data sets, data values, and then use either stdev or var function if you have an older version Excel, or if you can use stdev.s or var.s if you're using Excel 2010 or 2013. If you had to do it manually, you create the table such like this one. So say you're doing it manually, you list the numbers and you calculate the average, which in this case is 39.6. So you list 39.6 for all of them down here. And for each x, you take the difference between this and then this. So negative 10.6. You do the same for all the way down. And then for this cell, what you do is square this number, negative 10.6 squared. And you can do that by using that little hat, which is shift 6 and then 2. You did the same thing all the way down, and then you add up all these numbers. And then you divide it by how many there are minus 1. So in this case, there are 10 numbers, so I divided by 9. So you get the variance to be 45.8222. And to calculate the standard deviation, what you do is take the square root of the variance as square. So to do that, Excel function is sqrt, and you get 6.76921. You can also use Excel just to go straight to variance by using var function or var.s here. Select all these numbers, press enter, and you should get 45.8222, which is same as this, manually calculated. For the standard deviation, you can use either stdev or stdev.s. Select the numbers, press enter, and the numbers should match. So I recommend using just Excel to calculate the variance and then standard deviation. So let's go back to the notes. So there's a measure of relative standing, which is called a standard score or the z-score. And the formula for the z-score is whatever the data number is, you subtract the mean from it. So data minus mean over standard deviation. So this is called the z-score or the standard score. What the z-score tells you the following. At the mean, so that at the exact average, the z-score will be 0. So if you get a z-score of 0, that means you're exactly at average. If it's a positive z number, that means you're above the mean. And if you have a negative z-score, that means you're below the mean. So how do you read this? How do you use a z-score? Typically, you use that on the normal table. So here's a snippet of the normal table. So how do you use this? So if you have the z-score, say 1.0, or that means the same as 1.0 standard deviation above the mean because it's a positive 1.0. So according to the table, you're at 84.13 percentile. Similarly, if you have a negative 1.0 score, that means you're 1.0 standard deviation below the mean because you have a negative score or negative number there. So according to the table, you're at 15.87 percentile. So you can read the z-score and get the percentile. Or you can do the reverse. Look at the percentile and then try to guess what the z-score is. So for example, what would be the z-score for upper 10 percentile? That means you're at the 90th percentile. What is the z-score for the quarter percentile? That means 25 percentile. So you just kind of eyeball and see where's 90%. There's no exact entry for 90%, so you kind of have to kind of guess between 1.2 and 1.3. So for the 90 percentile, the exact number is 1.28, but you kind of have to guess that from reading from the table, read between the lines. Same thing for 25 percentile. If you go up here, there's no exactly 25 percentile, so but I know it's going to be between negative 0.65 and then negative 0.70. So I'm going to guess, which is probably going to be somewhere around negative 0.675. So you can take a guess. So that's how you read a normal table. Okay. Another thing you learned in this module is what we call the statistical significant. When you read the paper or somebody says highly significant or statistically significant, that means that whatever that you're talking about is probably true. It does not necessarily mean that whatever you're talking about is important. It just means it's probably true. And then we measure that by what we call the confidence level. Typically they're 95% and 99 percentile. The corresponding number is 0.05 or 0.01. So the margin of error for the 95% confidence level is calculated by this formula. Margin of error is 1 divided by the square root of n. So the margin of error is something like when you read the newspaper and there's a poll, there's typically says plus minus 4% margin of error, whatever that number is. The way to calculate that is this formula right here. And so the 95% confidence interval is found by subtracting or adding the margin of error from what we call the sample proportion, P, and there's a little hat there, like upper arrow. So that's called a P hat, which stands for the sample proportion. So the confidence interval you calculate by either adding the margin of error or subtracting the margin of error from the P hat. So here's an example. Let's say a survey of 1,200 people found that there's 47% plan to vote for a Democratic nominee. What is the margin of error and then the confidence interval? So this 47% is the P hat. So converting the 47% to the decimal, it's 0.47. The margin of error will be 1 over square root of 1,200, which if you do in Excel, it's going to be about 0.0288675. Or roughly 2.89%. So the confidence interval will be 47% plus minus 2.89. So if you do 47 minus 2.89, you get 44.11%. That's the lower end. And the upper end will be 47 plus 2.89 or 49.89%. So the answer to the question, if you ask for the confidence interval, you have to give two numbers. The lower number, which is 44.11, and the upper number in this case is 49.89%. So how do you do this in Excel? So let's go to that one. Same question. So in this case, n is 1,200. The p hat is 0.47. So the margin of error is going to be 1 divided by square root of 1,200. And to do the square root in Excel, its function is sqrt, short for square root. So I type in equal sign, 1 divided by square root, and then C10, which is 1,200. Press enter, and you get 0.02887. So to convert the decimal to a percentage, you just press this button here. Same for here. And then you do lower bound and upper bound. So in this case, it will be this minus this. And then for here, it's this plus this. Okay. For some reason, this gets too many decimal points, so let me shrink that. So 44.11%. 49.89%. So this would be a complete answer for the confidence interval. So this tutorial showed you how to do simple statistical calculations using Excel.